Assalamualaikum warahmatullahi wabarakatuh. We are from F4AS1202. We are going to present about application of differentiation of related rates. This is our group members.
Do you know what is derivative? The definition of derivative is the instantaneous rate of change of a function with respect to one of its variables. And do you know what is the related rates? The related rates are rates of change associated with two or more related quantities that are changing over time.
Next, let's move on to steps on solving related rates problem. Number 1, make sure that you understand the problem carefully and draw a diagram. Second, label all variables and rates of change with the appropriate units such as meters, liters, second, and many more. Third, write an equation relating the variable whose rate of change is to be found with the variables whose rate of change are known. Fourth, differentiate both sides of the equation implicitly with respect to time t and solve for the derivative that will give the unknown rate of change. 5. Substitute in the given values for all known variables and rate of change. Then solve for the unknown rate by isolating it on one side of the equation. And lastly is interpret and solve the problem. Let's take a look on problem statement and problem solution.
Question 1. A spherical balloon is being inflated at the rate of 8 cm cube second negative 1. Find the rate of change of the surface area when the radius is 4 cm. The one they are already given dv over dt is equal to 8 cm cube over s, and we're gonna find dA over dt, and radius is 4. So formula of sphere is area equal to 4 pi r square and volume is 4 over 3 pi r cube. And area is 4 pi r square. We're gonna bring square to the front and we're gonna get dA over dr is equal to 8 pi r, and we v equal to 4 over 3 pi r cube, and we're gonna get dv over dr is equal to 4 pi r square. So we're gonna find dA over dt. We're gonna use dA over dr multiply by dr over dv and multiply by dv over dt. So dA over dt is equal to 8 pi r multiplied by 1 over 4 pi r square multiplied by 8. So dA over dt, we're gonna use 8 pi, and we use the number 4 and multiply by 1 over 4 pi 4 square multiplied by 8. So we're gonna get 32 pi multiplied by 1 over 6, 34 pi multiplied by 8, and we're gonna get dA over dt is 4 cm.
Next question is, oil from leaking container radiates outwards in form of circular film on the water surface. If the area of the circle increases at the rate of 560 meter square per minute, how fast is the radius of the circle increasing when the area is 1654 by meter square? Let's see the solution for the question. We are given by dA over dt equals to 560. How fast is the radius? So we are going to find dr over dt. How fast means that we are finding something over dt. So how much is dr over dt when the area is given by 1654 pi? We already know that the shape is in circle, right? So we'll have the radius. The area for the circle is pi r square, and the area is given by 1654 pi. So pi r square equal to 1654 pi. We can cancel this pi because it exists on both sides. So r square is equal to 1654. So pressing our calculator and we will get 40.67 meter. So now we want to find dr over dt. We may start with dA over dt. So dA over dt is given by dA over dr multiply with dr over dt. Now we have dA over dt because it's given in the question, that is 560. Let's find dA over dr by differentiate this function in terms of r. So we have dA over dr given by 2 pi r. When r is 40.67, we can substitute the value r into this dA over dr. So we'll have dA over dr is given by 2 pi multiply with 40.67. We'll have 4067 over 50 pi. So just write it here. Then we're gonna find dr over dt. This is our aim. And our final answer will get 2.1 meter per minute.
Let's move on to the question number 3. If the radius of a sphere is increasing at the rate of 4 cm second minus 1, how fast is the volume changing when the surface area is 16 cm? Here's a hint given: volume of a sphere, which is 4 over 3 pi r cubed, and the surface area of a sphere, 4 pi r squared. So here is the diagram of the sphere, and the radius given is 4 cm, and we don't know the value of the volume, so we need to find it, and the surface area is 16 cm square. For the formula of volume of sphere is 4 over 3 pi r cubed, and the surface area of sphere is 4 pi r squared. So since V is related to R, to find dV over dt, we need to use dV over dr times with dr over dt for the dV over dr, which is the surface area of a sphere, 4 pi r square. So dV over dr is 4 pi r square times with dr over dt, which is 4 cm. So we get the answer is 16 pi r square. In this case, we need to find the value of r from the given surface area. So our surface area is given is 16 cm cubed. So 4 pi r square equals to 16, and r square, 4 pi will transfer to another side, so 16 over 4 pi. So we will simplify this, and we will get 4 over pi, and this square we will convert to another side, which is we will get square root 4 over pi. So finally we can find dV over dt, which is 16 pi r square, and the r value is square root 4 over pi. So we need to fill in the r, which is square root 4 over pi square. So we can cancel out the square and the square root. So we get here 16 pi 4 over pi. We times up all this, we get 64 cm cubed per second minus 1. So that's the answer. In conclusion, the concept of related rates allow us to analyze how different quantities change in relation to each other. Throughout this presentation, we explore the key component of related rates, including identifying the related variables, establishing an equation that relates to them, differentiating the equation with respect to time, and solving for the desired rate of change using appropriate technique. Last but not least, this is our reference.
Thank you for watching.